All right, so we're working on 2.4 today. I want to start, though, by reviewing some vocabulary that was on the top of worksheet 7. Can one of you get the lights by the phone? All right. All right, so at the top, it says the highest, this is on worksheet 7A. I still don't have a cursor that's working, really? Okay, there we go. Yes, I am, thanks. Thanks for asking, though. The degree highest exponent of a polynomial will tell you the degree, and the big number out in front of whatever that term is the leading coefficient. So even if we write something like this, it's degree what? Degree 3, leading coefficient 7. Now, what does the degree tell us? It is an odd degree, so yes, it does determine end behavior, right? Odd degree leading coefficient that's positive, the end behavior shape will look like this. It also tells us the maximum number of x-intercepts. Maximum possible number of x-intercepts. Yes. It doesn't mean there's necessarily 3. It could just be crossing once, but it could also have this shape, okay? So it's the maximum possible number. This is just some vocabulary. If you have a degree 1, it's linear. Degree 2 is quadratic. Degree 3 is cubic. Degree 4 is called quartic, okay? Basically, it's continuous if it's an unbroken curve with no jumps, gaps, or holes. It can also have no sharp corners. We're going to do a graph like this that is a like 2/3 power. And because of the sharp turn in there, that would not be a polynomial, okay? It is actually continuous, so I'm just confusing you there. It says the graph of a polynomial function is continuous. All right. End behavior, we just talked about. If it's odd degree and it had a positive leading coefficient, left end would be down. If it had a negative leading coefficient, sorry, that's supposed to say negative LC, would be going left end up, right end down. Oh my goodness, I can't draw today. Even degree means both ends are up or down. How could you tell? What would make both ends go down? Negative leading coefficient would make both ends go down. Positive leading coefficient would make both ends go up, and it might have loop-de-loops and it might not. Okay, the graph of a polynomial function has a y-intercept equal to its constant term, and at most n x-intercepts. So again, the degree equals the maximum number of x-intercepts or zeros. Yes, he's here. Xander, this is for you. Please come get it because I forget to hand them out all the time. Okay, multiplicity of zeros. When we have something like this, the multiplicities of the zeros are the fact that this has a 0 at 0, multiplicity 1, 0 at -5, multiplicity what? -5 would be a 0 of multiplicity 2, because the exponent on that 0 is 2. And then it has a 0 where else, guys? Anybody awake out there? What's the third 0 listed here? +4 with a multiplicity of? Yep. Okay. If the multiplicity is even, then it does what? When it comes to the x-axis, it just bounces or touches, but does not cross, okay? If it's an odd multiplicity, it crosses. So if I were trying to sketch this mess that I just wrote real quick, it had a 0 at 0, +4, and -5. So what total degree is that? Multiplicity 1, 2, and 3 would add up to a total of 6. So it comes to -5 from the top because it's a positive leading coefficient. It would bounce there, cross at 0, and cross again at 4. All right. The extrema or maxes and mins is the degree -1. Okay? The number of maxes and mins, which they will also call turning points, is equal to the degree -1. Inflection points is at most n-2, but we didn't really talk about that. One more calculator hint that's here, just since we're going over some polynomial graphing again today. Any polynomial function that's not linear, okay, so it's above degree 1, cannot contain a horizontal piece, a straight out horizontal piece, flat horizontal, okay? So therefore, you need to like zoom in and see what's going on there. It says no polynomial function of degree greater than 1 contains a horizontal segment. So make sure you zoom in and determine what's going on. Yes. Yes. Okay. So if you had like a negative odd degree, so you had a -2x to the 5th and some other junk, it would be a negative leading coefficient with an odd degree. So the left end would be up and the right end would be down. I don't know what it's doing in between here, but are you wanting me to write out what it would look like? The y is going up as x is going to the left, that kind of thing? Because these are even degree. Both ends are going the same, okay? Odd degree is opposite directions of the at two ends, okay? Even degree means both ends are up or down. Does that help? Yeah. Anybody else have a question? Please ask. I'd love to clarify. One should be confused. Okay, now we're going back to worksheet 6, right? Okay, there's a whole list of learning targets for this section. It says you can generate a list of all possible rational zeros. And that's what we talked about briefly at the beginning of the hour yesterday. I'm going to review that. Then you can find the real zeros by graphing and dividing. We've done some of that already. Then you're going to find complex zeros and be able to write a polynomial. All right, we did this a little bit yesterday at the beginning of the hour. This looks like this at the top of your notes. It says to create a list of all possible rational zeros. Tell me rational again. Rational means any number that can be written as a, nope, ratio, which means fraction, ratio, okay? So whole numbers count, negative numbers count, decimals that end, decimals that repeat, fractions, improper, mixed numbers, all of it. All right, so all of the possible rational zeros come from a list that is created by taking the factors of the constant term at the end, dividing it by the factors of the leading coefficient. You have to know which one goes on top, guys. All right, So we did this example yesterday. All the factors of -6 over all the factors of 1 just came out to be these. Then we graphed it. We determined that -2 was a 0. The depressed polynomial was here. Did we do quadratic? I feel like we skipped that part. Did we do it? Okay. So it was 7 plus or minus, was it 61 or something? Over 2? Okay, so the zeros were -2 from the graph here. And then 7 plus square root of 61 over 2 and 7 minus square root of 61 over 2. All right. And that came from quadratic formula. Our video was kind of messed up yesterday, so I re-recorded. But all right. Did we get to both of these yesterday? These were examples you didn't have. Yeah. Let's just, let me go through this one real fast, since you don't have them. And I know we probably did them yesterday, but it's what goes on top? The factors of the leading, the constant, you're right, over the leading coefficient. So all the factors of 21, do you like to write? I don't care what order you do them in. So if you want to do like 1 and 21 in that order, you can. I usually, in my head, just kind of go least to greatest. So I would say 1 and 21, 3 and 7, and that's about it, right? The factors of the leading coefficient, which is 3, are just 1 and 3. Now, the book would say you should list them all out. 1 over 1, plus or minus 3 over 1, plus or minus 7 over 1, plus or minus 21 over 1, plus or minus 1 over 3, 3 over 3, which is 1, we have that one, plus or minus 7 over 3, and 21 over 3 is 7, we already have that one. I'm going to make you list them out. The only thing I'm going to do is tell you you don't have to write plus or minus in front of every single one. As long as you put it out in front once, we'll be good. But you can't just leave it like this, because I want to know that you understand what that list means. It's easy points though, right? We can do this? All right, so let's try practice number 1. I think you have this. This one is easy. Why? The leading coefficient is a 1, so all we need is the factors of 20 over 1. What are the factors of 20? 1 and 20, 2 and 10, 4 and 5, that's it. All right, now to save time, because this is what takes me forever, I actually graphed it on the calculator here. Okay, I typed it in. Do I have it right? X cubed minus 5x squared minus 4x plus 20. This is what the graph looked like. Where does it appear to have a real 0? Okay, so 2. So if we think 2 is a 0, then we can do division to determine if it goes in evenly. The coefficients would be 1, -5, -4, and 20. Bring down the 1, multiply, add, multiply, add, multiply. Did it go in evenly? Okay. Now, we're supposed to be determining which other ones are zeros. Can this factor to find the other 2 zeros? What is this right here? 1x squared minus 3x minus 10. How does that factor, guys? X minus 5, x plus 2. So if they had asked us to factor it, we had this factor out front, it would look like this. They didn't actually ask for a factor. This time they asked which of them are actually zeros. So which of them worked, guys? 2. Does it look right on the graph? -2, +2, and 5. Okay. So pre-graphing calculator, Hofbauer had to make this list and then start trying numbers. As soon as I found one that worked, then I would use the depressed polynomial to find the others, okay? But I didn't have a graphing calculator to tell me how to start. I just had to start trying one, try two, try -1. Okay. The fundamental, is everybody all right? Did I go too fast? Okay. Yes, Keaton. On that one, because it didn't ask you to prove anything, yes. And they were all nice integers, you could have just found them on the calculator. Yep. On the quiz, there's going to be one that says, like, prove them, because you're going to have to show the division. Yep. All right. Complex zeros, guys, occur. Complex, remember when we talk about complex number system, it includes imaginary and real. So complex would be like a 0 of 2, a 0 of 3i, a 0 of -2 plus 5i. Those are all considered complex because they're real or complex. Or imaginary, sorry. Anything from that list, okay? It says a complex function of degree n has at least one 0 in the complex number system. Remember, that could mean real or imaginary. It says a polynomial function of degree n has exactly n zeros as long as you count repeated zeros. So if I have this, what degree is that? It's degree 3. And if I asked you or looked at the graph, we'd say it only had 2 zeros, right? It would have one at 2 and one at -5. But if you count the multiplicity here, then there's 1, 2, 3 zeros. Just says if you're counting repeated zeros, you'll hit that 3. All right. This is really, really important, but it's pretty basic. If you have a 0 at 2 plus 3i, you have to have a 0 at 2 minus 3i. As long as your polynomial had real coefficients going all the way across, your real imaginary, try that again, your complex zeros will come in pairs, conjugate pairs. The same is also true of irrational zeros, will come in conjugate pairs. So going back here to my example, if I had said 3i was a 0 for something, there would also have to be on my list a -3i because that's the conjugate. Do you remember that business? What is the conjugate of -2 plus 5i? Yes. You keep, I don't know what just happened to my cursor. If -2 plus 5i is a 0, then -2 minus 5i would have to be a 0. They have to come in conjugate pairs. All right. You have this example, but maybe it's done or not done on your paper. Is it already done for you? Okay. So it says, write a polynomial function of least degree with real coefficients in standard form that has 0 as a 0 and square root of 2 times I, which is not under the radical, as a 0. What else does it have to have? Guys, if it has square root of 2 times I, then it has to have the conjugate, which would be negative square root of 2 times I. All right. So if we're supposed to write the polynomial function, what is the factor that makes that? Just an x. How do I write this as a factor? Just x minus square root of 2 times I. What about this one? Okay. Now, it says this is where it gets messy because no one wants to have to do this, me included. We have to have real coefficients when we're all done. What do we have to do to make those into real numbers? Boil it together, okay? We have an x out here. If I FOIL this together, x times x is x squared. X times Square root of 2. I'm going to move the I out front. It's really bothering me. Multiply here would be a negative I squared root of 2 times x. Whoops, whoops, whoops. Get rid of that parenthesis. Awesome. Stupid cursor again. Go. Plus, I don't know what's going on today. What is negative square root of 2 times positive square root of 2? Anybody? Okay, it's negative 2, right? Square root of 2 times square root of 2 is 2, but there was a negative out here. So we have a negative and a 2. I times I is I squared, and I squared is negative 1 times this negative 2 will make it plus 2. These two terms drop out. All right, I had an x out front, and now all I have in here is an x squared plus 2. So if you wanted to finish foiling it out, you'd end up with this as your polynomial. Is that what's on your paper under this disaster? Okay. All right. Everybody take a deep breath because this one is miserable. All right. So it says find all complex zeros of this polynomial given that x equals 2 plus I is one of the zeros. If 2 plus I is a 0, you automatically know that, what's the conjugate? 2 minus I is also a 0. Now, this is where it gets nasty. If you say, I have a factor that's x minus the quantity 2 plus I, and I have another factor that is x minus the quantity 2 minus I, we have to have real coefficients, or we're supposed to figure out what the actual factor is. So we're going to practice a little fun here. First of all, let's distribute the negatives. So we would have x minus 2 minus I in this parenthesis, right, guys? And what's in this parenthesis back here? Okay. I'm going to FOIL these together. I'm going to show you a way to do this that I think is helpful. I'm going to FOIL the x to all three back here and just write it across. So I'm going to write x squared minus 2x plus ix. Everybody good? Now I'm going to distribute this negative 2 back here. But as I do, I'm going to write it underneath the like terms. So negative 2 times x is another negative 2x. I'm going to write it underneath there, okay? Just to line up our like terms. Now negative 2 times negative 2 is what? Positive 4. That isn't a like term with any of this, so I'm going to put it back here. And then negative 2 times I is a negative 2i that doesn't match up with anything. Okay, finally I have to distribute this I back there. I get a negative I times x. Yep, it's going to match up with that one and cancel it out. Then I get a negative I times negative 2 would be what, guys? Positive 2i, that's going to match up with this guy and get rid of it. And then negative I times positive I is negative I squared. I'm going to write that here because negative I squared is really what? I squared it, careful. I squared is negative 1, so when we have another negative out front, it's be a plus 1. All right, so now combine all your like terms. These dropped out. Oh, no, they didn't. Just kidding. Those didn't drop out. That's a negative 4, right? These dropped out. And These dropped out. So we had an x squared. What else? Minus 4x, and back here, plus 5. Now they suggest that we do some polynomial long division to find the remaining factors. Or it says we can graph. I'm going to do the long division down at the bottom of this slide, but you feel free to graph and find some more zeros for me. This is x to the fourth minus 5x cubed plus 3x squared plus 19x minus 30. You type that in. I hope some of you are finding some nice real zeros. I'm just getting a headache because my computer isn't working right. I got 3 and negative 2. Did anybody get 3 and negative 2? Okay. Yeah. So I did that by polynomial long division, and then this was the divisor, and I factored it. Okay? You guys graphed it. That was way easier. If they ask for linear factors, I don't have room, sorry. If they asked for linear factors, we'd have this, and the 2 we just found were x minus 3 and x plus 2. All right, I'm going to tell you right now, the one I put on the quiz that has eyes is not that messy. Okay, we're going to try practice 2. It says write a polynomial function of least degree with real coefficients in standard form. We are not going to do standard form that has the zeros negative 4i and 4 plus I. You may leave it in factored form, and it says that on the quiz, as long as you have real integer coefficients, which unfortunately means we have to get rid of the I. Okay, so negative 4 means we have a what for a factor? X plus 4. Or 0 at 1 means we have a factor of x minus 1. 4 plus I means there's also a 0 at 4 minus I. Okay, so how are we going to write those as factors? We'd have x minus 4 plus I and x minus 4 minus I. Can you distribute those negatives for me? Yep. It should be like this. I just want you to distribute the negatives so when we write it down here, it looks a little nicer. Can someone distribute that negative? And this one back here? Okay. I want you to try this. I'm actually going to stop the recording and give you 30 seconds. Try to FOIL those two together and see what happens. We can leave these out here. When we start FOILing all this together, What's a minus I squared, guys? Positive 1. So I got x squared minus 8x plus 17 because these canceled and these canceled. Did anyone get that? All right. Would you like a trick? Because that's just so much fun. You don't want to necessarily do it. Okay. There is a trick. The zeros were 4 plus I and 4 minus I. I need you to find the sum and the product of those zeros. The sum means to add them together. So what is 4 plus I plus 4 minus I? We just get 8. Do you see where that showed up in our answer? Okay, this was the opposite of the sum right there. The product, if I foiled the two zeros together, I'd get 16 minus 4I plus 4I minus I squared, which is 17. That's this number. So the rule is if you take the original two zeros, the two complex zeros, and you find their sum and their product, you have to change the sign here, though. It's opposite of the sum plus the product. By the way, does that work all the time? What if I had a 7 and a negative 3? What's the sum of those? The sum is 4. Opposite of the 4. And what's the product? Is that true? Those factors multiply to make this? It's always true, yep. It's always true, whether they're complex zeros or not. All right. When you have a question that says you need to find, it needs to be irreducible over the real numbers, that just means you can't factor it any further without getting imaginary numbers, okay? Every polynomial function with real coefficients can be written as a product of linear factors and irreducible quadratic factors. All right. So number 4, we're supposed to do a whole bunch of stuff up here. It says write it as a product of linear and irreducible quadratic factors, then as a product of linear factors, and list all its zeros. Start by graphing. I graphed this disaster for number 4 and got this. I don't know if you can see from the back, but I tested and negative 6 was a 0. I also found a real 0 over here at 4. Okay? Everybody paying attention? Had real zeros at negative 6 and 4. So we have to do synthetic division of successively, in other words, one after the other. Anybody care? Do I do negative 6 or positive 4 first? Negative 6. 1, 2, negative 15. Do I need any placeholders? Okay. You are going to have to do this on the test. I didn't necessarily put a degree 4 on the quiz, but okay, bring down the 1, multiply. What do I get? Add. Multiply. 9, multiply. I think I added right. Negative 54 plus 18 is negative 36, maybe? Yep. Negative 36 times negative 6 is positive 216. Has to come out 0 if it worked on the graph or you did something wrong. Do not go back to the original polynomial. We're going to keep going with this depressed little polynomial here, poor little anxious thing, and put in a what? The positive 4, the other 0. Bring down the 1. 4 times 1 is 4. Add and we get 0. Multiply 0. Be careful. Add is 9, multiply. Okay. So what are our factors? The answer to A, x squared plus 0x plus 9, right? So we got an x squared plus 9, and what are the other two? X plus 6, right? And x minus 4. Okay, that is part A because it is now linear factors. These two are linear. And a quadratic that does not reduce, right? B says we have to write it as linear factors, which means let's find the zeros first. I don't know why they don't do it in that order. What are the zeros? Negative 6, positive 4. How do we find these two? Does it factor? No, but we can solve it by doing what? Square rooting, and we get, it's going to have i's, yep. Square root both sides, and we get x equals plus or minus 3i. So 3i and negative 3i are the other two zeros. So linear factors means everything has to be factored with an x only. You'd have an x plus 6, an x minus 4, and an x what? Good job. An x minus 3i and x plus 3i. Okay. Linear factors means you're going to have to be able to leave some i's in there, because your x's can't have an x, a power. All right, wasn't that fun? Okay, number 5 is another one of those, and that's the last one. All right, so I graphed this disaster. Please remember that, okay? I saved time by graphing them for you, but you need to graph them to start, because you're going to do your homework tonight, and you're going to, okay, just kidding. 2 of you are going to do your homework tonight, but anyway, you have to remember that you start by graphing, okay? And the directions on the quiz even say that. All right, so I graphed it. I got a 0 at negative 3. 4, negative 15, 43. Oh, please tell me someone has a calculator ready to help me here. Bring down the 4. Times negative 3 is negative 12. Add is negative 27. Multiply is 81. Okay, now I might get stuck. 124 times negative 3. Is it 372? So we add and get 205. How did I do? Times negative 3 would be negative 615. Okay, we must have done it right because we came out of 0. I want to mention here, if you're taking the quiz and you're positive you graphed it right and you had a 0 and it's not coming out a 0 at the end here, bring it up to me and go, I know this is supposed to be a 0, Hofbauer. What am I doing wrong? You're probably doing 1 times 1 is 2 or something. You know what I'm saying? Or 1 plus 0 is 1. Well, that would be right. 1 plus 0 is 0. Okay, but if you're making a silly mistake and you know it should be coming out right, just bring it up. I'll help you find your silly mistake. Okay, we have to have another real 0. So, I looked and thought this was negative 1, but is it? Nope, it's actually negative 1.25. Yay! Okay, help. 4 times negative 1.25, negative 5. Okay, so then we get negative 32 times negative 1.25 would be positive 40. 164 times negative 1.25, sure hoping is negative 205. Okay. All right, guys, this is really important. We now have a reduced polynomial that we can factor, but what do we need to do first to this? Factor out a what? Can we take a 4 out of all those? So we'll have an x squared minus 8x plus 41. What? Oh, that's gross. That means we're going to have to do quadratic formula. All right. So to find the remaining 2 zeros, I'm going quick here. We have to do quadratic formula. Opposite of b plus or minus the square root of, what's negative 8 squared? Minus 4 times 1 times 41. It's going to be imaginary, right? All over 2 times a, or 2. What's 64 minus 4 times 41? I got negative 100. Did anybody get negative 100 in there? Okay. So if this is really the square root of negative 100, so we're going to have 8 plus or minus 10i over 2. Can we reduce that to what? Four plus or minus 5i. Good job. All right. So the answers to part C are 4 plus or minus 5i, negative 1.25, and negative 3. That's part C. Part B, part A, I'm going to go back and write here because we had this 4 times this. What were the other two factors? X minus 1.25 and, no, X plus 1.25 and X plus 3. So there's the factors. Okay, B wants linear factors. I didn't put linear factors on the quiz. Would that be good news? Yeah. It would be 4 x minus 4 plus 5i, x plus, no, just kidding, minus 4 minus 5i, x plus 1.25, and x plus 3. Okay, so you should be working on these problems tonight. So Lillian, are you going to be able to come sometime or what? Tomorrow? You're all good. You missed 2 days? Hope you can watch some videos.
I will.
Okay.